Solve the following rational equation. Show the answer as a solution set. The rational equation we have is 1 divided by x equals 1 divided by 5 plus 3 divided by the quantity 2x. Our first consideration is what values are restricted, that is, that would cause the denominator to be 0. Because our denominators are x, 5, and 2x, the values that make any of those 0 is x equals 0. So I'm going to include here x is not equal to 0, and that is because x, 5, and 2x, any of those would be 0 when x is equal to 0. Connected to this, we need to determine the least common denominator, the LCD, and that's going to be a multiple, the smallest multiple of those three denominators, x, 5, and 2x. The least common denominator here is going to be 10x, because that would be a multiple of x, a multiple of 5, and also a multiple of 2x. Now we'll take this least common denominator and multiply each term by that expression. So 10x parentheses 1 over x, close parentheses, equals 10x, open parentheses, 1/5, close parentheses, plus 10x, parentheses, 3 over the quantity 2x, close parentheses. Each of these expressions will simplify. That is actually how we determine the least common denominator. So 10x divided by the denominator x will be 10. So the left-hand side becomes 10 times 1. That is the numerator. On the right-hand side, 10x multiplied by 1/5, 10 divided by 5 is 2, so this simplifies to 2x times 1, that's our numerator, plus our second term, 10x multiplied by 3 divided by 2x. 10x divided by 2x will be 5, so this becomes plus 5 multiplied by 3. So our new equation is 10 times 1 equals 2x times 1 plus 5 times 3. We can multiply those out and say that this is going to be 10 equals 2x plus 15. And from that equation, we can subtract 15 from both sides to see that negative 5 equals 2x. And if we divide by 2 on both sides, we see that x equals negative 5 over 2. As a solution set, that would be an open brace, negative 5 over 2, and a closed brace. Before we declare that is our final answer, that is correct, we need to go back and compare to the restricted values. We said that x could not be equal to 0, and x is not equal to 0, it is negative 5 over 2, so we can accept that answer. If we find that our x equals value is in conflict with the restricted value, then we will restrict that value, we will eliminate that or reject it. In our next question, solve the following rational equation, show answer as a solution set. Our equation is x over the quantity x minus 3 equals 3 over the quantity x minus 3 plus 9. Again, we ask ourselves what values are restricted, what values would cause the denominator to be 0, and the only denominator that exists in this question is the quantity x minus 3. Well, x minus 3 equals 0 whenever x is equal to positive 3. So the value that is restricted is 3, so we'll write x is not equal to 3. And again, our least common denominator, looking at our denominators, the only one is x minus 3, so I'm going to use, my LCD is parentheses x minus 3, close parentheses, that quantity. We will multiply each term in this equation by x minus 3. So parentheses x minus 3, open parentheses, x over the quantity x minus 3, close parentheses, equals parentheses x minus 3, close parentheses, open parentheses, 3 over the quantity x minus 3, close parentheses, plus open parentheses x minus 3, close parentheses, and then multiply by 9. the factor of x minus 3, that quantity, is going to cancel in the first expression. It will reduce in the first expression to be so that we have x on the left-hand side. And the first term on the right-hand side, x minus 3, also reduces, so we're left with 3. Plus, in our last expression, that will be 9, parentheses, x minus 3, close parentheses. So x equals 3 plus 9, open parentheses, x minus 3, close parentheses. If we distribute the 9, this equation becomes x equals 3 plus 9x minus 27. And we can combine the terms 3 and minus 27 so that our equation becomes x equals 9x minus 24. And I believe I'll subtract 9x from both sides. So x minus 9x is negative 8x. And that will be equal to the negative 24 we have left on the right side. And then finally we can divide by negative 8 so that x is equal to positive 3. Now it is at this point that I want to say solution set is 3. However, x equals 3 is in conflict with our statement that x is not equal to 3. So this equation has no solution. So as a solution set, that would be an open brace and a closed brace with nothing inside. And in words, this would be no solution. Okay. In our next example, solve the following rational equation. Show answer as a solution set. The equation 3 over the quantity x minus 1 equals 1 over the quantity x plus 2 plus 9 over the quantity x plus 2 multiplied by x minus 1. So two expressions, x plus 2, x minus 1 multiplied. All right, thinking about the restricted values, what values are restricted that would cause the denominator to be 0, we need to consider the two denominators, x minus 1 and x plus 2, the two factors in our denominators. X minus 1 would be equal to 0 whenever x equals positive 1, so x is not equal to 1. And the factor x plus 2 will be equal to 0 whenever x is equal to negative 2, so we say x is not equal to 1 or negative 2. Now, our least common denominator, looking at all those factors, it appears that our least common denominator will be x minus 1 quantity multiplied by the quantity x plus 2. So we're going to multiply every term, every expression in this, by x plus 1 in parentheses, multiplied by x plus 2 in parentheses. Okay. So let's fit that in here. Parentheses, x plus 1, close parentheses, open parentheses, x. I apologize, that is x minus 1. All right, so parentheses, x minus 1, close parentheses, x plus 2, close parentheses, that's multiplied by 3 divided by x minus 1, equals x minus 1 multiplied by x plus 2, each of those in parentheses, multiplied by parentheses 1 over x plus 2, close parentheses, plus x minus 1, x plus 2, again, each factor in parentheses, multiplied by 9 over parentheses x plus 2, close parentheses, open parentheses, x minus 1, close parentheses, and then that whole expression in parentheses. So, in the first term on the left-hand side, the x minus 1 factor reduces, so we're left with 3 parentheses x plus 2, close parentheses. Our next term, x minus 1 times x plus 2 times 1 over x plus 2. The x plus 2 factor will cancel, so we're left with 1 multiplied by x minus 1. And then our last term will have a plus, and x minus 1 times x plus 2 multiplied by 9 over x plus 2 times x minus 1. The x minus 1 factor reduces, as so does the x plus 2 factor, so we're left with 9. So our new equation is 3 parentheses x plus 2 close parentheses equals 1, open parentheses, x minus 1, close parentheses, plus 9. Now if we distribute the 3 on the left-hand side, that will give us 3x plus 6 equals, if we distribute the 1 on the right-hand side, that will be just an x minus 1 plus 9. 3x plus 6 equals x minus 1 plus 9. We can combine the like terms, negative 1 and positive 9, so that our equation becomes 3x plus 6 equals x plus 8. And I'm going to subtract x from both sides to collect my x terms. So 3x minus x is 2x. So 2x plus 6 equals 8. I'll subtract 6 from both sides so that 2x equals 2, dividing by 2, x equals positive 1. As in the last question, that value is in conflict with our restricted values. We said that x could not be 1 or negative 2, but here we have determined that x is equal to 1. So our solution set is open brace, close brace, and that is, in words, no solution. Our next example, solve the following rational equation, show answer as a solution set. We have the equation 1/3 minus 7 over the quantity 4x equals 1/4 minus 1 over the quantity 6x. So we want to consider our denominators, and we can ignore the constants. We have 3 and 4. Those are two denominators. Those don't affect our restrictions. So we can consider 4x and 6x. Value would make each of those expressions 0. Well, that would be x is 0. So x is not equal 0. That'll be our restriction. And then our least common denominator needs to be a multiple of 3, 4x, 4, and 6x. So if you think through multiples of 6, we find that 12 is a multiple of 3, 4, and 6. So 12, and then we need a 12x as so our LCD is 12x. Let's multiply every term by 12x. So 12x, open parentheses, 1/3, close parentheses, minus 12x, open parentheses, 7 over the quantity 4x, close parentheses, equals 12x times 1/4 minus 12x, open parentheses, 1 over the quantity 6x, close parentheses. Each of these denominators will simplify. 12x divided by 3 is 4, so our new equation, our first term will be 4x times 1, or 4x. Our second term, 12x divided by 4x, would be 3, so we have minus 3 times 7. 7 was the numerator, of course, equals 12x divided by 4 would be 3x, so we have 3x times 1, which will be 3x. And then minus for our last term, 12x divided by 6x, that would be 2. So that's minus 2 times 1, or just 2. I'll go ahead and multiply my 3 times 7 for my second term, so this becomes 4x minus 21 equals 3x minus 2. And we subtract 3x from both sides. It gives the equation x minus 21 equals negative 2. And then we can add 21 to both sides, so that x equals positive 19. Now, thinking back to our restricted values, we said x could not be 0. Here we have found that x equals 19, so that is quite likely a valid solution. So my open brace 19, close brace, and my solution set. I haven't done this on any of these questions, but it is also a good idea to plug or evaluate the value we find for x that we propose as the solution back into the original equation. That's the only way really to guarantee that it's a solution to that equation. I feel quite confident in our work so far, so I'm confident we didn't make any arithmetic mistakes or anything like that. So I will not check this, but I would suggest that. All right. For our last example, solve the following rational equation. Show answer as a solution set. 3 over the quantity x plus 4 minus 7 equals negative 4 divided by the quantity x plus 4. We'll again look at our denominators, and there's only one denominator, x plus 4. It appears multiple times. X plus 4 is the only expression we have in a denominator. X plus 4 would be equal to 0 whenever x is equal to negative 4, so our restricted value is x is not equal to negative 4. And our least common denominator will be the expression, parentheses, x plus 4, close parentheses. Now, we will multiply every term by this, so we will have parentheses, x plus 4, close parentheses, open parentheses, 3 over the quantity x plus 4, close parentheses, minus parentheses, x plus 4, close parentheses, multiplied by 7, equals parentheses, x plus 4, close parentheses, open parentheses, negative 4 over the quantity x plus 4, close parentheses. So in the first term, x plus 4 divided by x plus 4, that will reduce so that we are left with 1 multiplied by 3. So our first term becomes 3. Second expression, nothing reduces, so this will be minus 7, parentheses, x plus 4, close parentheses, equals, our last term is x plus 4 divided by x plus 4. That's just 1. So we are left with the numerator of negative 4. So our equation becomes 3 minus 7, parentheses, x plus 4, close parentheses, equals negative 4. I'm going to distribute the negative 7. So this becomes 3 minus 7x minus 28 equals negative 4. Now I can combine 3 and negative 28 as like terms. So this equation becomes negative 7x minus 25 equals negative 4. There we can add 25 to both sides. So that negative 7x equals 21. And dividing by negative 7 on both sides, x equals negative 3. Now again, thinking back to our restricted values, x cannot be equal to negative 4. The value we found is negative 3, not negative 4. So our solution set is open brace negative 3, close brace.